In nuclear fusion, two low-mass nuclei combine to form a more massive nucleus, whose binding energy per nucleon is greater than that of the original nuclei. Each nucleus has a positive charge. In order to overcome the strong repulsive force, the short-range strong nuclear force can pull two low-mass nuclei together, leading to fusion if they have large kinetic energies and hence large temperatures to start with. As an example, in this deuterium-tritium reaction, a temperature of about 100 million degrees centigrade is needed. These reactions are called thermonuclear reactions. The most important such reaction occurs in stars such as our own sun. A hydrogen bomb is an example of human-made fusion reaction. Now these two isotopes of hydrogen, deuterium and tritium, fuse to form helium and a neutron according to the following reaction. We will calculate the energy that is released by this particular fusion reaction later on, and we will also study this curve, which is number of nucleons versus binding energy per nucleon. Thank you for watching.